Hello everyone, this is Maurizio, editor-in-chief of Power Electronics News and Embedded.com, and I am at Electronica, showcasing in Munich, in this wonderful location. And today I am here at the Würth Elektronik booth, and I have the pleasure to be here with Alexander Gerfer, CTO of Würth. Hi Alexander, thanks a lot for being here. How is it going?
Thank you, Maurizio, for the invitation and the time. Thanks, doing well. And a very interesting show today, absolutely.
Yeah, indeed. Thanks a lot. So Electronica is one of the most significant trade shows in the electronics industry. So my first question, what's news from Würth? What key technologies are you showcasing in these days?
Well, we have several news. Of course, in our traditional field of the power inductors, we have some new power inductors. So molded power inductors with lower losses in class, now we're the best, so to say. And with even lower DCR, the MXGI it's called in ours. Then we of course support the idea of more efficiency by coupled inductors, the TLVR inductor solutions. Coupled inductors is one of the key technologies for new power application designs. Then we have high current connectors because you have high currents on PCB boards, but how to bring away. So around inductors and magnetics is the so-called press-fit technology, red cubes we call them. Very important. We show some new cases and solutions here. And of course then really, really high power wire wound inductors for really high current stuff, which we had not in that extent before.
Thank you. So my first question for you is the second question, is about sustainability. Sustainability is growing focus into different industry, across industries. So how is Würth integrating sustainability into product development and the related processes?
Well, sustainability is a big word, okay? So it starts from the design of the component. So wherever we can, let's say, make a component more simple, less production steps, means I have to have less things to do on a certain point of winding or welding or whatever. So a more simple component means less production steps, so more or less a faster production and less failure impacts. And then, of course, driving this product to a high production yield, high quality output, so I have less waste in my production. We are just on the way on releasing a new inductor type. It's not shown here because we are still on the way to do that, but we can even bring down waste to a minimum in the power inductor technology. That is one of these things. And then, of course, underlining the problem of efficiency in power design. When we go on like this, as we do right now, all the power needed for AI-driven solutions, high power usage, it needs more efficient power designs. And we are, the magnetics, under high pressure because gallium nitride, silicon carbide, we know, super nice switches.
Yes.
And the magnetics are under high pressure now to make these losses as small as possible. And again, coupled inductors are here a good way to solve this. But it's a mix out of circuit design or switcher and switch mode design, and how is it made, and the inductor, how the winding is set up. And this is a good way we were on, but not at the end. We are still working on improvements step by step. We can showcase some of these solutions here already on the booth. Yeah.
Sure. So let's talk more about electrification, about energy efficiency. So with the growing interest in terms of electrification, energy efficiency, in particular market about automotive, industrial automation. So and there is a lot of challenges, a lot of development. So how is Würth contributing to this transformation? Not only electric vehicles, probably also talking about transportation. That is a huge market.
Also for automotive or the e-mobility or let's say e-cars, of course, there is where we look into the market and look for, let's say, other ideas and traditional designs of how to make my charging station. We have some nice examples already where we can say we support these startup ideas, also new ways how to charge my car, but it needs, of course, and that's a bit the situation we have, the smart network, the smart grid. That is really what is needed to be able to really distribute the power in this big field of charging stations to the best and under the sufficient power maximum in the network. That is still needed. Then on the other side, for industrial solutions, we find very interesting now the upcoming DC grid in the factories, because then we can save some of these converters where you go from AC to a DC, and here you can really save some of the converter stages.
Sure.
Eventually not good for us because we lose eventually a PFC choke. Yeah, but overall the designs get more efficient and you get more flexibility in connecting several devices in such a grid. At this time it's a bit of very young technology, I would say, but the outlook is really very positive and the power impact is huge. 5%, 6% energy saving in an industrial environment means a lot of energy savings, especially when energy cost is so high as it right now. So DC grid in a factory, in a new factory setup, is where I say very important. Okay, some small things still to solve, but it's all on a good way. Here I see a very good positive impact coming up. Yeah.
Great. Okay, good. So you are CTO of Würth Elektronik. So what is your leadership philosophy? Well, so how do you promote, how do you foster culture of innovation?
I hope it's done by leadership by example, you call it. Yeah? Also I hope that I can say and showcase to my teams that I work every time against the no. The no's we normally in Würth Electronics or in Würth in general, we don't accept the no. We want to understand the no. And why is the no in the field and how can we surround this or solve this no into a yes, whatever that means, and really understand where are limitations and then find solutions around it. And we implement it very early in our design teams, design thinking, agile in hardware design, to let them really room to go out of processes, so to say. Yeah? That's where we motivate them to do, to think out of the box, not staying in the box, go to see conferences, technical conferences, consume knowledge, and bring yourself to a better knowledge level and try things out. Things can go wrong, but if you don't experiment, if you don't do the experiment, you never know. So yes, you can make a failure, but not by purpose, right? By an experiment, it doesn't work, wonderful, but now I learned what will not work, for sure not work, so find the next solution. So we hope that we can motivate people really to go by leadership by example. I made my mistakes, of course, but at least the sum of the positive things is more important. Yeah,
from mistake you can
Absolutely.
learn. You can learn for sure. Of course. So next question. So the global semiconductor, the electronics market, all of these has seen challenges, in particular supply chain during the last year. So how you are working in this market? So what strategies to guarantee a resilience in terms of supply chain, in terms of resilience looking forward for the market that is a fast evolving market?
Very important is the close contact in between the customer to us. So at an early stage to understand where are you in your design stage? What is your next design coming up? What is it based on? As which IC solution or whatever semiconductor solution is in behind, that we earliest know where this train could go or will go. And we sum it up in our case with many, many designs. And then we try, even in the design, to give some guideline. If you really want to go this small size, or it's eventually better to go 2 steps larger in size, then you have a long-term availability guaranteed. It's easier for your EMS to eventually to put it on the board. It has, because bigger size means, especially also for capacitor, sometimes a better DC behavior and so on. So to really think twice before I finalize my design, to make it to more available components, less DCR means less heating. Less heating means less lifetime impact. So I have a longer prolonged lifetime normally with less heat in the design. We have a lot of solutions also here with heat spreaders or how to get the heat out. That's really the challenge now for high power electronics. Low heating, if there is heat, how to get the heat out of the design. So that is where we work on to bring this in. And then we know from all this mix how to arrange our productions best. And we can buffer, of course, goods in our warehouses. But the most important point is earliest communication and clear communication about the demand and no overreaction. No, if I need 1,500, I need 1,500. Don't order 10,000. We are so summing these parts up and have 10,000 in behind in total. This brings a lot of pressure out of the supply chain channel and, of course, price raises and so on. Also, talk to us about your design, your true demands, and we will find the best solution for you as a customer to solve this and being best on time.
So let's talk about manufacturing with the increasing in terms of digitalization of manufacturing. So how you are leveraging the digital tools, Industry 4.0, the next probably 5.0 tools in this regard.
Yeah, good. In the factories, of course, what was made mainly on paperwork and then too slow reaction times on what impacted now this SPC numbers going wrong directions. Now to have it more online and on the fly, so to see this parameter set is going eventually in the wrong way. Why? And then immediately look back the processes before, what was changed, what was impacting here, to again get the yield, production yield in the higher output. For the designers here in taking our components, we have the tool Red Expert. We have a lot of measurement data inside. So if you select, if you compare different, let's say, technologies of the same component level and then simulate that what I do here on my digital twin is close to my reality. So my first answer from simulation should be very close to reality. Let's say plus minus 5% on the on the output tolerance, so to say. Because then I need one less design of my breadboard design, so to say, my first prototype. Or my first prototype is so close to what I need and no big surprises anymore in the design. Then I save time. That is because we measure a lot of data. We feedback the data again, even from our production lines into the measurement of components. And you have very, very reliable data set for me as a designer outside world. And I can from this go in my digital twin close to reality. That's where we drive and support this idea of digitalization into a positive impact of my designs.
So my last question for you, Alexander. So looking forward, looking to the future, what excites you the most from the future, from the direction of Würth, from the electronics going forward, and what key message you would like to give to next innovators, next young engineers?
As we need hardware designers. Your job is very important to us, to every one of us. We have just talked about the energy efficiency. You need really hardware designers doing that because power is a thing. Every device needs power, and we have different power levels. Yeah, absolutely. And that has to be really super efficient. Our energy sources are limited, and those we have to make the most of it. And especially when we think about the scale up of devices, we have to bend the curve of energy consumption and can also be bent by more efficient designs. That would, for me, as a young engineer talent, a very challenging thing. And especially on the magnetics, we have a lot of things to do. The end is not there. Many things, the questions we raised up in an APEC show several years ago from my side was really how would AI design the power inductor best efficient when I go out of normal things I know. How would I design, or how would AI design such an inductor? So many, many things where we need creativity, co-working together, thinking out of the box, where we think even a young generation can go here even faster and still very committed and make a positive impact to the designs, absolutely.
So a lot of technologies, a lot of business.
Yeah, don't be bothered by all these technology things. We have a lot of very good basic knowledge to know, that's clear. Mathematics, of course, you have to know a bit mathematics. But then it's fine, you have even tools for that. But don't be shy. Study electronics, make hardware. Besides software, is hardware the key, what we need.
Okay, thanks a lot, Alexander.
Thank you, Maurizio.
Thanks a lot for your time. Thank you.
Thanks very much for the interview. Thanks.
Thank you.